wishes, hoping all of you are good and is safe during the pandemic. True Unova wishes all of you a very happy day. In today's session, let's learn about an important concept found in the engineering branch of computer science and engineering. The subject of choice is design, analysis and algorithm. And the concept choice for today's session is Prim's algorithm. Questions related to how, why, when, where, what should all be addressed in this session. Concept Clarity Initiative, acronymed as CCI, is a classic effort of True Unova in helping students clarify any academic doubt digitally. This video on Prim's algorithm shall be treated as an example of how True Unova's Concept Clarity session works. Best wishes. What is Prim's algorithm and how can it be used in real world? Firstly, what is Prim's algorithm? A greedy mechanism opted to find a minimum spanning tree from a given cyclic graph. A cyclic graph? What does that mean? A graph in which the start and the end node is the same, leading to an infinite loop, is called a cyclic graph. On the other hand, an acyclic graph is called as a tree. Here you can see there is no loop. Loops include no self loops, neither no integrated loops. The next question is to find out how this MST from the given graph shall be derived. To understand that, we need to understand the element of how and where. Let's understand this concept with a very simple example. Pack your clothes and put yourself into the shoes of an avid traveler. Assume that you are right now at Chicago, waiting to explore the 7 continents of this world. Let us name each continent with an alphabet. A as North America, B as South America, C as Africa, D as Europe, E as Asia, F as Australia, and finally G as Antarctica. The alphabets are the nodes of the given graph. The path or route to each continent is the edge. And the values indicate the amount you need to spend to travel in that particular route. Say something like a toll fee. Do relate this graph to your question given in the exam paper. To avoid any confusion while calculation, we shall follow a matrix. We shall record each possible traversal in a matrix form. The from and the to. For example, from North America to South America. Since it is not defined, here we have put as infinity. One more example. From Europe to Antarctica. It is not defined, hence we are using an infinity. You need to initialize every value to infinity. As you see, E, which is colored in gray color, indicates a continent that you are yet to visit, and an alphabet in a circle of white colored circle indicates that you have completed the traversal. We also maintain a list to understand the continents, the way, or how do you say, the ordinal number of what continent comes at what number. Since you are initially stationed at Chicago, we are starting with continent of North America. There is only one principle to understand. Travel along the minimum edge. Now, since you are a traveler, you will have to save money to travel and visit all the continents, isn't it? So, you need to reduce the amount that you can spend to see all the continents. And that example can be understood with this principle, that is, travel along the minimum edge. Let's break that concept, or let's break that graph into small portions, starting with node A. So node A is North America, node B is South America, node C is Africa, node D is Europe. To travel from North America to South America, you will have to give, say, $5. And from North America to Africa, you will have to spend around $3. And from North America to Europe, you will have to spend $17. We will initially jot down all the possible values of the given edges into this matrix. So A to B, that is North America to South America, as 5, A to C as 3, A to D as 17. Now your choice should be the value or the toll fee which is very minimum. Here you can see that value 3 is minimum. Hence we are choosing the choice as 3, and we have confirming that we are visited the continent of C, that is Africa. So our MS set, the minimum spanning tree set, is of the order after North America, you will have to visit Africa. Next, you will have to find the adjacent nodes, that is of the visited continents. You might have, say, F will have very least value, or E can have another least value, but you should not take that. Instead, you should choose the one from which you have visited. So your possible choice is only from A and C. A connects to these continents and C connects to these continents. Now, of this, which is the least value? Since A to C, A to B and A to C is, A to B and A to D is already jotted down, we are not re-jotting it. We shall fill in the other values. C to D, that is value 1, C to E, that is value 7, C to F, and that is value 30. So you can indicate this black colored ones as not visited, okay, or yet to visit, and the red colored ones as visited or the confirmed routes. Now if you see which is the least value, yes, you're right, the answer is 1. So we are going with the choice after North America, you are to visit C, that is Africa. After Africa, you are to visit D, that is Europe. So your MS set will be in such order: A, C and D. Now before we go on to the next page, now tell me, can I find out what are the next possible route from E? Yes, it's not possible because we have to find the next edges or the next nodes connect only based on what we have already connected. Now you might have a doubt to understand. So now you see, is this a cyclic graph? But we have not chose this. So in the next step we will be eliminating this edge, since we have visited A, C and D using this. I hope you remember, we are trying to find a minimum spanning tree and not a cyclic graph. So as said, look at A, C and D. This edge is removed since we have already visited A, C and D. There is no need of edge A to D. Now from C we have already written E, we have already jotted down the value of F. The remaining value that we are to jot down in this particular page is only D to E. What's the value? The value is 28. So if you see, the value here is 28. Initially that was given as infinity. Now it is made to 28. Now you see, you can go into any node that you have not visited. It's not compulsory after D, it should be E, or after D, it should be F. There is no compulsion. Your only value or your only motive is to travel with minimal fee or with minimal toll fee. So if you see, what is the minimal value that you can see? It is 5. Since this 5 is already written, we are not rewriting it. Instead, we are just making it as a choice. Okay, so if you see, the indicated value of red color is 5 and the node that is visited is also highlighted. Now you might have a doubt. So if it is A to C to D, okay, now should I come back from D? So D to C, say 1 plus 3 plus 5, which is more than the value of C to E. That's not how you should check. You should check only this edge value. Don't take it as a traversal. So after D, if I'm coming to B, what happens? You should not think like 1 plus 3 plus 5. That's wrong calculation. It's very simple. Only choose the minimum edge. If the C to B is of value 0, then you can go to C to B. You don't really have to go to A to B. There is no particular value. There is no, since I hope you can understand, this is not a directed graph. Like you have to come like this, A to B, then B to C, or C to, this is a not directed graph. That is an undirected graph. So you can just choose the minimal value. Next, so the set here includes A, C, D and B. Now tell me, what is the next least value? Is it D to E 28, C to E 7, C to F 30, B to G 25? What's the value? 7. Good. So the value 7 is to be indicated. Now tell me, what happens to this edge? Very good. It will be eliminated. So the path will be A, C, D, B and then E. I hope you're clear. We shall only take the least value of the edge. We shall not count it as an addition, not like 5 plus 3 plus 1 plus 7. It's not like that. It's only 7. You have to just give direct link. Okay. So you see, the edge here is deleted since we are to find a tree and not a graph, not a cyclic graph. Now tell me, what's the next node that you can go to? E to G or E to F or C to F or B to G. What's the least value? You have, I think I don't have to repeat, because you can see that you have to keep adding all the values that the edges are, of the weighted edges are, to this particular matrix to avoid confusion. Right now we have only visited 5 nodes, and for 5 nodes we have 4 edges, 1, 2, 3, 4. Right? So if you have visited 6 nodes, you will always have, you would have seen or crossed 5 edges. If you have 7 nodes, you would have crossed 6 edges. So it's always 1. I hope you know that n into n minus 1, that value is written. What is n into n minus 1? Here n is the number of nodes and n minus 1 is the number of edges. Right. Now can you tell me what's the least value? E to G. E to G is F. I'm sorry, E to G is 8. So we are choosing that value because there is no other least value. Hence we are choosing 8. So you have visited, what is the order? A, C, D, then B, E, G. So A, C, D, B, E, G. I hope you remember, I had initially said you should not change the order. Whatever order you get, you should just place it that way. Don't think like A is after A it should always be B, or after B it should be C. It's not like that. Here it's a minimum spanning tree where you're traversing after each country. After what country you have to visit which country. So that's the example that you have to pull into this minimum spanning tree. Right? So can you come to the next one? The last one. So how am I to visit Australia, the last continent? Shall I visit it from Antarctica, or shall I visit it from Asia? Or shall I visit it from Africa? Very good. You have to visit it from Antarctica because that's the least value. So G to F. So that's the final value. So if you take what happens to this edge of 30 or this edge of 9, what happens here? It will get, edge of 9 is already accepted, yes, okay. What happens to this value of 30? So it will be eliminated. Before that, let's first finalize the root. A, C, D, B, E, G, and then F. So this is the final MST. What is MST? Minimum spanning tree. You have to traverse across all the edges and find the minimum value. And using that minimum value, you should meet all the edges. You should visit all the nodes. It's not that you can leave Africa and then go to Antarctica, or leave Australia and go to Europe. It's not like that. You have to visit all the 7 continents. Since you're a traveler and you love to travel, you have to visit all the continents. But your only motive is to reduce the amount that you are using to travel. So here, this same concept is used in minimum spanning tree, where you are reducing the amount, or you're choosing the least edge, the least valued edge. Now, so tell me, can you just quickly tell me what's the root that we have just seen? Yes, to help you recollect, let's go on. First, we have to visit North America, since we are in North America. And then we are to visit Africa, then to Europe, then to South America, then to Asia, then to Antarctica, and finally to Australia. I hope you must be clear on how True Unova makes an effort to clarify concepts. When applicability meets concept, you should never forget what you have learned. To enquire about how to get enrolled for such concept clarity sessions, you can follow the enquiry list or enquiry form attached in the description. Other important links such as official pages or official video recordings and all of that can be found in the description below. Thank you, and I hope all of you to have a very happy day. Best wishes, RR.